Hey there, Mr. Sutton here. I've got the Pre-Cal Honors 3-2 Extra Practice number 2 solutions on multiplying and dividing rational expressions. To simplify this expression, we're going to first turn our division into multiplication. So I can use same change flip here, keep the first fraction the same, change this to multiplication, and then flip or take the reciprocal of the second fraction. So the 42v cubed minus 18v squared is coming upstairs, and then the other stuff is downstairs. Now before I multiply these, let me factor and cancel whatever I can. The only thing that actually can't be factored here is this v plus 2. Everything else can be broken up. So the lower left now, it looks like I can take out a 4 and a v from all that. That leaves me with 7v minus 3. And then in the upper right, well, let's see, 42 and 18. Those are both divisible by 2. And actually 6. 6 is even better. So I can take out a 6 and a v squared. That leaves me with 7. And then 7v actually, because we had v cubed taking v squared out of that. And then we're subtracting 3. Now down here, I can take out a 6v squared from there as well. Well, that's a nice coincidence. So that leaves me with a v plus 4. And in terms of things I can cancel, these 7v minus 3s can definitely go away. And I can cross-cancel those because I'm multiplying the fractions. And then these 6v squareds also cancel. I mean, I could do something with this 6v squared and this 4v, but if I have the chance to completely cancel this out with the other 6v squared, I mean, why not, right? So now in the numerator, all that's left is v plus 2, and downstairs we have a 4v and a v plus 4. For this division problem, let me first turn this into multiplication by using same change flip, or multiply by the reciprocal. So the first fraction stays the same. This division turns to multiplication, and we flip this fraction to be 8n over 10. So now let me cross-cancel. I'm allowed to cross-cancel some things, or just cancel in general. I've got multiplication going on, so if I do need to cancel crosswise, I'm allowed to do so. But first, right away, I don't even need to cross-cancel to get these n squareds. Those are in the same fraction, so those definitely cancel. But now it looks like the 4 and the 8 could cancel out. So that leaves me with a 1 down here and a 2 up there. But wait, there's more. This 2 that I just got and this 10 down here also can reduce. So that leaves me with a 1 up here, and now I have a 5 downstairs. So what's left over? In the numerator, we have a 9 times n, so 9n. In the denominator, this whole lower left got canceled, so all that's left is this 5 over here, so 9n over 5. To simplify this rational expression, I'm first going to factor and cancel whatever I can. And, I mean, I see right away that I can cancel these n plus 6s, but let me just factor everything. So we'll leave the n plus 6s there for now. And now, in the lower left, I can take a 2n out of this expression. That leaves me, if I take out a 2n, with n plus 6. And in the upper right, I can also take a 2n out of that one, leaving me with an n plus 2. So it looks like the n plus 6 is either this one and this one, or this one and this one can cancel. Half a dozen of one, 6 of the other. I'll go with cross-canceling, which I'm allowed to do because we're multiplying the fractions. And another reason I'm actually going with this n plus 6 and not this other one is they gave me this n plus 6 in the beginning of the problem, so I know that's correct no matter what. This other n plus 6, I'm pretty sure about it, but I got that one on my own. So, you know, if I mess this up, then at least it's less wrong if I cancel out those n plus 6s. Okay, so what else can I do? The two n's actually can completely cancel as well. So all that's left over at this point, we have an n plus 2 in the numerator and n plus 6 in the denominator. To simplify this rational expression, I'm going to reduce things before I multiply, although it's not going to save me a ton of time on this one. Usually it does, though. So let's see, there's a few options I have. I'm actually going to cross-cancel the 6 and the 8, which I'm allowed to do because I'm multiplying the fractions. So this 6 is now going to be a 3, and dividing the 8 by 2, we get a 4 down there. But wait, before I do anything else, the 2 up here and the 4 down here can also reduce. So that leaves me now with a 1 up here, and this 4 now becomes a 2. All right, multiplying what's left over, we still have a 3n to the 4th upstairs. And down here we still have this 5 times the 2 that's left over, so that's 10. And just checking one more time, it doesn't look like I can reduce or simplify this more, so I'm calling this one done. To divide these fractions, let me same change flip on this one. So keep the first fraction the same, change this to multiplication, and flip the second fraction. So the reciprocal of that second one then is 4 over 6v. And again, we now have multiplication of that. And before I actually do multiply, let me factor out and cancel what I can. So it looks like the v plus 10, the 4, and the 6v are as good as it gets over there. But this expression in the upper left can be broken down a bit. If I take out a 6v, that'll leave me with a v plus 10. And now it looks like I can cancel a few things. For example, these 6v's would cancel completely, and I am allowed to cancel them. I can cross-cancel because I am multiplying the fraction, so that works only with multiplying. And now these v plus 10s are in the same fraction, so those would cancel no matter what. And what's left? Well, I have a 4 in the numerator and an invisible 1 in the denominator, so that's just 4 over 1, or just simply 4. Before I attempt to multiply these together, let me first factor and cancel whatever I can. I mean, that's not going to be easy, but it's going to be way easier than multiplying and then trying to factor it. So the x plus 3 is good to go. Everything else can be split up, though. In the upper left, I need factors of -6 that add up to 1. 1 and 6 won't work, but 2 and 3 works if you have -2 and +3. So I can write x minus 2, x plus 3 for that one. In the lower left, it looks like I can factor out a 4 and an x squared. That leaves me with x minus 2. And in the lower right, we can take out a 3x, leaving me with an x and a plus 3. What cancels? Well, the x minus 2's definitely cancel. And it looks like this x plus 3 and this x plus 3, or these two x plus 3's, whichever one you want to choose, those are going to cancel as well. So I'm just going to cross-cancel here, which I'm allowed to do because I am multiplying the fractions. And it looks like there's nothing else I can cancel out. So let's multiply what's left. In the numerator, we just have the x plus 3. In the denominator, I have 4x squared times 3x, which I can multiply together. So that's going to be 12x cubed.